Hello, this is Ollie from 9904N, and I'm here to explain background tasks in my code is the third part of my little code series. Okay, so start with the task handler. So I covered this at the end of my last video on organization. Essentially, what it does is um, it makes each task an object. I can create the task, I can pull for it, and see if I need to make it run in the background. Additionally, I can print if it is running or not on the brain screen. Okay, so for our color sort, this is third, maybe fourth version of color sort I've made. I've made a lot of them, and before I had trouble getting like my optical sensor to accurately tell me if like what color the ring was, or I guess this year would be block, or in the future it'd be other things. But if it's red or blue. So I used to use .getHue, but now I do get RGB. And I find this is a lot more effective. So essentially, what it does is the more it looks at the object, the higher the value of like red, like red, blue, green will be. And if it's red, it'll be like really high, and if it's not red, like I checked the dot blue, it's going to be pretty low. And the more it looks at it, the more confident it gets, which is something I found that the dot hue doesn't really have. As well as you don't have to tune this, but you have to tune the like get the hue ranges or whatever with that function. So I found this is really effective. And if you see here, for testing, I find it very important to get feedback on like what the values the computer is getting. So if you run the integrated terminal, so you just like plug your computer up to the brain when it's running, you can see in the console like I print like the red values, the blue values, like what these are, stuff like that. But if you get rid of all of this, the actual Ringsort code is pretty small. So okay, essentially this right here, that is all of like, that's the only part that actually gets the color. And I was like the most consistent one I found. So essentially just make it really, really simple. And this RGB is just makes it like, it gets a color profile of what it's seeing. And I think the update is around like every 100 milliseconds or something. And normally it would get maybe like it would get like one color profile of the ring, and it was pretty consistent. But whenever it got two, it was like always right, because that means it had a good amount of time to look at it. So, and then the next part is, so whenever the ring is near, which is just this bool function I made, the intake or the LED would turn on. That just helps for consistency, seeing the right color. And then after that, we have throwing off the ring, and it would also rumble the controller just so I know that it threw on the ring on purpose, as well as it would flash the LEDs in our drivetrain white, which is the main. If you look at like our Autonza world, you can see when it flashes white, that's because it ring sorted. And the thing is, we found through testing and printing like the values I got from updating on the console, I found that the optical sensor doesn't update the distance it sees as fast as the distance sensor. So the color was always correct, but if I use the optical sensor to tell me if like when it stops seeing the ring, then it would sometimes throw it off too late or too early. While the distance sensor, it was like, I think updated every 20 milliseconds compared to every 100 milliseconds. And so the way that I made that very easy to change is the ring near function here. I used to use optical.getProximity, now I just do intake distance.getDistance. So yeah. Okay, that's my color sort. Now let's go to my LB PID. So the way I did my PID is whenever I run it, I'll get an example. The simplest version is just LB2 like vertical angle, and vertical goes to 125 degrees, where 0 is where it's resting, but normally I have it where 3 is the resting, so that it has a little bit of leeway around where it sits, so if it ever goes down, it goes maybe to 1 instead of 355 and messes up. So I had it where when it runs, there's all these different parameters I can pass down to it, but I only have to, the minimum I have to pass is the angle, and that way I can make it like, if I have to code something fast to keep it simple, I just say like LB go to vertical. Additionally, I can say, do I want to block the main thread or make it as a task? What's the exit range, or like what angle or how close to the final angle should I get? Like the stable time, the timeout, stuff like that. And that's really helpful for tuning like specific movements, like scoring in the aligned stake really quickly, while not making it too complicated every time you use it. So, and I of course make it as a task that runs in the background, and I use a mutex so that if for example, like let's say that this wasn't blocking the main thread and I ran both of these at the same time, the second one wouldn't run or would wait till this one finishes, because the mutex makes it wait until the mutex is given back at the end here. Yeah, and as well, so actually the main function that I interact with is the to function, where of course is in the LB PID or LB main space. So I just do like LB2 and then I pass these. Now, yeah, these are optional. And then if I say do not block the thread, and then or if I say don't block the thread, it makes a task. If I do, then it just runs it like normal. As well, I have so for my error, how I find that, I use a function to get that if I can find it. Let's see. Okay, encoder angle. So this is where I get my error from. Error equals target angle minus encoder angle. But what's useful about having this as a function that you like check for, instead of just saying like rotation sensor angle here, is that if I'm using IMEs, which means that I check when I initialize, I check if my rotation sensor is unplugged. If it's unplugged, it says, okay, we're using IMEs true, then it'll return the motor encoders. So that's like a good backup. So, but it'll return to the same place as the rotation angle would. And just a thing that comes up is it's kind of hard to tell, but the rotation angle in pros gives back centigrees, so you have to divide it by 100 if you want to get like a normal angle that you'd interact with. But yeah. Okay, so one last thing for the PID. If you want it to hold in place, don't do do break mode hold. Don't do break mode like break, because this will like stop it, but it will not like deliberately hold it in place. Break mode hold will hold it in place. Okay. Next is my hook unjam or intake unjam. So essentially what this does is it looks at the torque. So okay, intake, actual velocity, are we not moving? Yes, okay. It also checks, are we trying to move? So target velocity is greater than 0 essentially. And is the torque greater than 0.3? 0.3 is just a number I tuned. It works well for me. You can test that out. But yeah. And then this is pretty much it. It just checks, is this true? If so, unjam the intake or whatever. And you could also use this, I mean, high stakes is over, but you could use it like checking if a ring is scored in the Lady Brown, stuff like that. Okay, DcDetect. So this one is my most complicated one. So what I wanted to do is I wanted to check if anything is unplugged, any motors, any rotation, any like sensors, stuff like that. So what I do is I made an array of all my sensors, or all my devices, sorry. And then I iterate through that array, and then I run this, let's see. I think, where is it? Oh yeah, okay. So device, I iterate through all of these, calling it device, or maybe this, I don't remember. And then if pros specifically, you can check if something is plugged in or not. And if it returns that something is unplugged, like any of these when it iterates through it, then it will buzz the controller and like it will like show on the controller screen. It'll like say, oh this here, this will update my controller screen task, and it'll like buzz the controller, say like what's unplugged. Yeah, so that's really helpful. So that means that when we put our robot on the field before a match, we plug everything in, we look at the controller. If nothing's buzzing, that means we don't have to like check all the motors, like everything's plugged in, we're good. And then that means if during a match the controller starts buzzing, then that means we know what's not working essentially. Yeah, and then I check. So every 3 seconds I make a new check for this, and then I wait 15 milliseconds between each one, and that's responsive enough for me while not using too much power. Now this one I wasn't able to implement it into my like TaskHandler thing because it was a little bit too unique with like checking all these devices and stuff like that. Okay, so and then next we have our screen print. Let's see. Okay, so I print on the brain screen and I print on the controller screen. And before, when I did this, I just had a really big file, like a really like huge file with just like everything in line. But I found that it's a lot better if you put everything into functions, because if you want to remove something, move stuff around, change the order, you just move the functions around really simply. And right here is where I print the status of the background tasks that I'm running. And I don't want to use too much power because this is all a task running in the background, and it does a lot of stuff every time it runs. So essentially this just like I think runs it 1 in 5 times it would normally run, or maybe like every 100 milliseconds, I don't remember. Yeah, let's see. And for the controller screen, apparently you can't print them really really fast, so that also helps with it, because if you print them like every 5-10 milliseconds, it just like won't show anything, or only will show one line. Yeah. Okay. And of course I print the drive temperatures and whatever, and pros gives it to you in Celsius, so you have to move it to Fahrenheit. Okay. And okay, let's go to Autoclamp. So I also use a bunch of bool functions where I can check this. And what's good about this is I can, since this is used multiple places in my code, I can like change this, tune this without having to scavenge for every place it's used. Yeah. Okay, so we check, is a goal detected? And I've had previous versions of this too, but the simplest was the easiest to tune and the most effective. So that's what worked for me. And the logic behind it is pretty simple. The only thing is, if when we're holding a goal or we clamp down, the only thing about it that's different is we keep checking if we let go of it, because sometimes it would fire on accident because it just barely sees something. But being able to like continually update its position, or like know if the goal is there, means it can unclamp and reclamp again. Yeah, and this plugs in with our ODOM, where, okay, this is the function we use for ODOM, where it's like poll, I pass the X and Y functions we're going to move to when we poll, and then I say, if we miss and we're gonna back up again and clamp the goal again, these are the X and Y values I want to go to afterwards, and I just pass these to lemlib, of course. And this early clamp distance, you'll see it in my Auton video, but this is how many inches the bot has to travel before it starts looking like trying to auto clamp the goal. And this is helpful because if we do it when we're accelerating, if we like clamp when we're accelerating, sometimes it'll knock the goal away before it clamps, but if we do it when we're decelerating, it will. So this is just helpful for tuning. Yeah, so we see, okay, wait until the goal, set the clamp is true, or else we run the fallback, And this, yeah, that's pretty much it. Okay. Thank you for watching, and I will make an Auton video where I explain my my world's Auton and how I use all these different processes and background tasks to make an effective Auton. Thanks for watching.